Tonight what we are going to be talking about are separation techniques. So how do we separate mixtures into their individual compounds or elements? The way that you do this is basically by their physical differences. So what do they look like? So their appearances. What particle sizes do they have? So are they larger particles compared to smaller particles? Their solubility. So do they dissolve in certain substances whereas the other ones do not? And then also the biggest one that we're going to be talking about is boiling point and melting point. So different phase change temperatures. The first one we're going to be talking about does it by particle size, and what it is filtration. I always think of a coffee filter. Why? Because it works the exact same way that these high-end filters that we use in this class work. So what you do is basically you have your mixture and you'll pour it through a funnel into this filter. And what's going to happen is that the solid will stay above because they are of a larger particle, whereas the liquid will go through. So an example from sand and water, you have your mixture of sand and water up here in this test tube. The sand will stay above because it's too large to go through the filter paper, and then the water will be able to go through. So you can separate sand from water very easily. Another technique that we'll be using is evaporation. And what evaporation does is it separates based off of boiling point. Okay, this is a very low-key separation technique, and what that means is that it's very simple. So the equipment that you use is very simple and the process is extremely easy. So this is the one you want to go to if you possibly can. So what you do is you heat it up. So we're going to pretend we have salt water in this dish. And what happens is because the water has a boiling point that is much lower than that of salt, the water will boil off and then you will be left with salt in the dish. The problem with this technique and why you don't always want to use this is because if you ever want to capture that actual water, okay, so let's say for whatever reason you need the salt and the water, then this would not work, because what happens with the evaporation is that the water just goes away and you are left with just salt. So it does a good job of separating it, but if you actually need the water or the one that has the lower boiling point, this will not work. Distillation also, it's the higher end one of basically kind of evaporation, and what they use is this huge device which I'll go over, and they separate it based off of the boiling point. It's really nice to separate some anything that's dissolved in a liquid. You definitely need to use it, it definitely needs to have at least one liquid component in order to use this. We use this to separate crude oil into their different uses that we use, such as petrol, kerosene, and diesel, which make up our big crude oil. It also helps when you're dealing with distilled water. So what it does is it'll separate the pure water from all the impurities that are found in water. So here's the distillation apparatus, I guess. Here's a round bottom flask, okay? And what it does is it separates based off a boiling point. So I'm going to kind of describe this one. So let's say in this we have something that boils at 70 degrees, and I'm going to say those are the purple dots. And then let's say we've got something that boils at 100 degrees, and those are going to be the blue X's in this. So we've got a few blue X's, and we have a few purple dots. Okay, and what you're going to do is you're going to heat up this round bottom flask. Okay, you can use either a hot plate, a burner, or whatever, some sort of heat source. And what's going to happen is because the purple dots have a lower boiling point, they are going to become a gas at a lower temperature than that of the blue X's, which have a boiling point of 100. So the purple dots are going to become a gas, and because gases are less dense, they are going to rise. These gases are going to go through, the purple dot gases are going to go through this clear tube, okay? And it's still a gas at this point. What it's then going to do is go through what we call the condenser, and this condenser is very expensive. It's over $180. When I broke one in my college experience, that was devastating because I was broke. That was like a month's run at that time. So what this condenser is it's actually surrounded by very, very cold water. Okay, so you can see the water in the dark blue on this. And when this gas goes through this thin tube, it's now surrounded by extremely cold water. So what does it do? It goes back to a liquid. And because of gravity and how you have it set up, the liquid will now flow down the tube and be caught into this flask. So now at this point, we have all of the purple dots in this one flask, in the Erlenmeyer flask, and we have all the blue X's only left in this one. So you have separated both liquids from each other, okay, based off of their boiling point, and then you now have both of them still. So unlike evaporation where you lose the water, in this case you keep the water and the salt separate from one another. But this is an extremely expensive apparatus, so you don't want to use this unless you absolutely need to. All right, so what would a heating curve look like if a substance had a boiling point of 50 degrees and another substance had a boiling point of 25 degrees? So I'm going to say that that will not work on this color. I'm going to use a 25 degrees is going to be yellow, and then I'm going to say that the 50 degrees is going to be this light blue color. Okay, and so originally what's going to happen is that they are both going to heat up at the same rate. So at this point I have both my yellow and I have my blue particles in this. But as soon as I hit that 25-degree mark, so right here, that guy is going to start to separate and to become a gas, okay? And I will be left with the blue still heating up until it hits that 50 mark. At 50 degrees, it too will undergo the phase change of going into a gas, and it will start leveling off also as far as temperature goes because it's being converted into a gas. Crystallization works the way, think of rock candy. So what you do with crystallization is basically you dissolve a solid in a liquid and you heat up that liquid so much, or now the mixture so much, that you can actually dissolve more in it, okay? And then what happens is when you allow it to cool, because the liquid can no longer hold all of that solid, the solid will start to crystallize or recrystallize again. This is how they make rock candy. So they put a lot of sugar in it, and then they heat up that sugar and water combination. They put a string in there, and then the sugar will crystallize when you start to cool it onto that string. So now you're left with pure sugar on that string. Electrolysis is the only one that actually can separate compounds that we will talk about. And what we use in this class is the Hoffman apparatus. And the Hoffman apparatus is this guy. And what you basically do is you have this water, okay, right here, and you shoot electricity through it. So obviously to break up a compound, it takes a lot of energy. So in this case, we're using a lot of electricity. And what can happen is that this water breaks into its components of hydrogen and oxygen. Okay, and so when we shoot this electricity through it, it actually breaks apart those bonds of the hydrogen and oxygen and makes hydrogen and oxygen separate. So this is the only one that can actually separate compounds that we'll ever talk about, and you need a lot of energy to do this. Okay, where would they use this? Well, they would use this on the most common one that I would think of would be a nuclear submarine. And why do they care about separating water into hydrogen and oxygen on a nuclear sub? Well, first off, they have a lot of energy from their nuclear power plant, basically, or the nuclear reactor that's found on that submarine. So they've got a lot of electricity, a lot of potential of energy. So they've got the resources. The other thing is that it's a submarine, and so submarines' whole purpose is to go below water, and unfortunately humans need oxygen in order to live. So, and when you're underwater, obviously you don't have a resource of pure oxygen just readily available. So what they do is that they separate the water that they're surrounded by in the ocean, and they separate into the hydrogen and their oxygen components. The oxygen they then use in the submarine, and the hydrogen they just shoot out and put it back into the ocean. So that's why, so the nuclear submarine can stay underwater almost indefinitely until they need to resurface actually due to food, not because they need to allow the people to be able to breathe.